Hey guys, go ahead and get out your note sheet for properties. Most of this should be review, and there will be a couple new properties that we're going to look at the end, so here we go. Alright, so your first property is distributed property, and the definition is that you can multiply a number outside of parentheses by each number in the parentheses, and you would get the same result as if you would just add first in the parentheses and then multiply. So you've got two different examples at the bottom, if you want to put those in your examples page. And basically, again, that distributed property says that you can, instead of adding what's in parentheses and then multiplying, that you can choose to multiply everything by the number on the outside. So this would really become 4 times 2 plus 4 times 6. And then if I wanted to keep simplifying, then I would have 8 plus 24, which is 32. And again, that comes the same answer would be as if you just did 6 plus 2 first to get 8, and 8 times 4. The example on the right is more typical of why we do use distributed property in algebra, and it's because when you have a variable in parentheses, you cannot subtract because we don't know what x is, like when we solve equations. So in order to solve an equation, you would have to use distributed property. So that would become 2 times x minus 2 times 1, and then we could just call this 2x minus 2. Second property is one you've been learning for a lot of years, the commutative property. And commutative property says that you can change the order of adding or multiplying without changing the results. Something that I always show my students to kind of remember this one is the CO for commutative property can stand for changes order. And it's kind of a nice way that the spelling actually tells you what the property is stating is that you can change order. So the two examples I have is for addition. You might have something like 4 plus 3 plus 2, and that would equal the same thing as if we wanted to change this to maybe 4 plus 2 plus 3 and get 6 plus 3 instead of doing 7 plus 2. Again, you'll get the same answer. For multiplication, if you see 7 times 5 times 8, maybe you don't want to figure out what 35 times 8 is if you went left to right, but if we redo this and maybe do 5 times 8 first to get 40, and then 40 times 7, it might be a little easier for you to figure out that answer because 4 times 7 and then add a 0 would be a little easier again. Alright, so next we have associative property, which states that you can regroup parentheses around numbers being added or multiplied. Please add that in, I forgot to type it, in the same order without changing the results. So, important concept here is that it needs to be same order, and you're just regrouping or moving parentheses. Something with associative property to help with the way it's spelled is if we take ASSO, it can stand for always stays same order. Meaning you're going to see the numbers in the same order, but just having the parentheses shifting places. So we have 8 plus 12 plus 9. Again, maybe you don't want to figure out what 8 plus 12 plus 9 is 21. Maybe you would prefer to do 8 plus 12 first, so shift our parentheses, which is 20, and then add your 9. Same thing for multiplication. Right now you would do 4 times 45, but if you shift those parentheses, you can do 20 times 9, and again, that's probably easier because 9 times 2 with a 0 is a little bit faster than maybe 45 times 4. Okay, next property is identity property, and this can be used for addition or multiplication. I put the definitions in different colors, so you can add 0 to any number. That would be your identity of addition, and multiplication would be or multiply any number by 1, and then both of these share the second ending without changing the results. So you can add 0 to any number without changing your answer, or you can multiply anything by 1 without changing it. The way I usually teach people to remember identity is if you don't want somebody to change your identity, you shouldn't want somebody to. So what can you add to something without changing it would be 0. What can you multiply without changing the identity would be 1. And then there's just a couple of different examples at the bottom. So obviously if you do the easy math here, 8 plus 0 would be 8. Y plus 0 is y. Notice that you're starting and ending with the same results. For multiplication, negative 8 times 1 is negative 8, and then 1 times x would just be x, or 1x. So again, you can clearly see you always start and end with those same results for identity without changing something. Okay, inverse property, again, I have different colors for the addition versus multiplication. So inverse of addition says that you can add any numbers opposite to get the answer of 0, or you can multiply any number by its reciprocal to get 1 as your result. So at the bottom, we've got a couple different examples of addition and multiplication. So addition means you take a number and then you add its opposite. So if we start with 7 and then we add -7, our answer would definitely be 0. If you start with -x and you add +x, then your answer again would be 0. So inverse of addition is just adding opposites, and we're making 0 pairs basically. For multiplication, you're taking a number and multiplying by the reciprocal, which is ultimately flipping it. So -2 really is -2/1. So if I was to flip that, I'm going to have -1/2, and then -2 times -1/2 is +1. 2/5 times 5/2, so you can reduce everything, or you can just multiply and call that 10/10, which would ultimately simplify to 1. So inverse of addition, you want 0 as an answer. Inverse of multiplication, you want 1 as an answer. Only trick way I know of helping to potentially memorize this one or distinguish between is inverse. It has that letter V, and then the word evil has a V. I don't know, it's just a weird way of remembering for me. Evil meaning it's going to make numbers change and going to make things kind of, messy. Unlike identity where things stay the same, inverse makes them change. Here's your super easy property because the property name actually states what you do. So the multiplicative property of 0 is when you multiply a number by 0, your answer is 0. So your two examples, anything times 0, x squared times 0 is 0, -2 times 0 is 0. So that one's kind of basic. So here's one of your new properties. Reflexive property states that a number equals itself. I truly don't know why we learned this property because it's super basic. The examples would literally be a number equaling itself, so 2 is 2 or x is x. I guess they have this as a property so that you know if you have a problem that might have like multiple x's, like 2x plus 5x minus 4x. I guess knowing that reflexive property where x is x, that basically says that every time you see x there, it should be the same value. Easy way to remember reflexive is thinking of reflection, and if you were to look in the mirror, you're going to see you, so you equal you or a number equals itself. Another new property is symmetric property, and symmetric property states that the order of equality, which is equal signs, does not matter. So something to point out with the symmetric property, it's always going to have an if and then statement in it, and basically it's a reverse. So it's taking something from the left of an equals and moving it to the right and flipping from which side of the equal sign. So examples you might have, if A equals B, then B equals A. So we can reverse the side of the equal sign and it wouldn't matter. When it's really used, and the reason why this property is helpful, is when you have equations, and when people see equations that typically look like this example here, 8 equals 2x minus 4, I know a lot of students who do not like to solve it when your variable is on the right-hand side of an equal sign. So the true property that states you can flip-flop that around is this symmetric property, and we can technically rewrite that so that your variable is now on the left and it's 2x minus 4 equals 8 instead, and then you could solve for x. So symmetric property is all about kind of symmetry where you're going to flip-flop those sides of the equal sign. And again, it's always if and then, which is kind of a nice helpful reminder to pick it out. Okay, and then we have transitive property, which states that two numbers equal to the same number are equal to each other. The definition might be a little bit weirder or harder to understand, but one way to remember transitive property is if you think of transitive and kind of think a little choo-choo train, and here's my really generic choo-choo train. Transitive property has 3 parts to the problem, so it's the only one where it's a 3-part problem. And if you look at the examples, here's the 3 parts. So if A equals B, and B equals C, then A equals C. So there's your 3 parts. Also, this is an if and then statement. So it's basically saying if A is B and then B is C, since these both share a B, then we can conclude that A and C are equal. Where it probably makes more sense to you guys is the second example. And so if we plug in actual values and we say that 1/2 equals 0.5, and then we also know 0.5 is 50%, then we can conclude that 1/2 is 50%. Again, because they share this 0.5, that means that A, or 1/2 and 50% are also equal. And your last property is substitution property. So it states if A equals B, then A can be replaced by B. And it's really just saying that you can simplify or substitute values in to make true statements while you're solving. So if you look at the examples, it might make a little bit more sense. Substitution for this first example would be us actually exchanging what 5 plus 2 is. So we know if we actually did the addition of 5 plus 2, that's going to be 7. So what we're doing is we're substituting that 5 plus 2 is 7, and there's your substitution. In the second problem, if I look at doing this, the only thing I can really do is exchange 4 times 3 with what it is, and that's 12. So my substitution is exchanging 4 times 3 with what the value is 12. So this is really just doing math, and we can call it substitution property. Okay, so I have some practice ones that you can take a look at. These are not on your notes, but if you want to just take a look at your notes or don't use your notes if you don't want, but try and name each of these properties, and you can pause the video and then you can press play, and I'm going to go over what the answer should have been. So number 1, you're multiplying by 0 to get 0. That should have been multiplicative property of 0. Number 2, that 10 plus 2 changed to a 12, so that's going to be substitution property, and I'm going to definitely shorten these as I write them out because I'm a lazy writer. Number 3, if 2 plus 3 is 5, then 5 equals 2 plus 3. That's symmetric property where you can flip-flop the sides of the equation. Number 4, if 5 times 2 equals 10 and 10 is 5 plus 5, then 5 times 2 is the same as 5 plus 5. That's transitive. That's that if and then statement, and it's 3 parts. Number 5, 6 plus negative 6 equals 0. So this, adding negative 6 to 6 is making it go away. That's the evil one. That's your inverse property of addition. 6, 1 times m equals m. You start and end with m, so something's not changing. That's identity. 7, k plus 7 is k plus 7. That's basically saying the same thing is itself. That's your reflection or reflexive property. Number 8, x plus 0 equals x. So again, you're starting and ending with that same value. That should be identity, this time of addition. And then number 9, you have 11 times 1/11, which creates 1. So you're multiplying by a reciprocal to make a number change. That's the evil inverse property. So if you want to go ahead and try and pick this property out and then press play to check your answer and see if you get this one right. Okay, 0 plus anything equaling itself is that identity property where you're not changing the value. So it should have been option 1. Second example, if you want to again pause and see if you can figure out which property this one is. Okay, this should have been your substitution, and if you take a close look, it's changing that 6 plus 2 to what it is, which is 8, and you're basically substituting that value out. And last example, go ahead and pause and see if you can figure out which property is shown here. This one might be a little trickier to see, but it's there. Okay, this was actually, again, that identity property. So what I do notice is 2 plus didn't change. And if you look at these parentheses here, what did change is that the left side has that times 1, the right side does not. And that's basically proving that if you multiply by 1, you're not changing something. The back of your note sheet, if you would like to try and do some of them, you can, but we will also review these when we get to class, so you don't have to do the back of it if you don't want. And I will see you guys soon.